Kepler's first law. Simply put, Kepler's first law states that the Earth's orbit is an ellipse with the sun located at one focus. So that's a simple statement of it. Over the next two lessons, we are going to talk more about what that means and go over some of the geometry associated with this. So ellipses are shapes that are similar to a circle. And if we look at a circle, first thing we want to consider is how to draw a circle. Now this picture down here shows a little pin with a string and a pencil. And what that string does, if you move it in a circle, like so, is it keeps the distance between the pencil and the pin constant. That distance is known as the radius. So what this does is allow us to draw a circle with a constant radius. Now the key terms, which should make common sense to you, are that there is the center of a circle. And we can also consider a circle as being plotted on a graph that has two axes. A major axis and a minor axis. Now in a circle, these lengths, this minor length and this major length, are equal to each other. They're equal in length. And that's what actually defines a circle. A circle has major and minor axes, which are the same length. Now, this major axis is actually the entire distance, the diameter. And 1/2 of it we can call the semi-major. And semi means 1/2. So if our major axis is this entire length, and the semi-major is 1/2. Similarly, the minor axis, which is this whole distance equal to the diameter, 1/2 of it is the semi-minor axis. Now, of course, this makes no difference in a circle because they are similar. But as you might guess, in an ellipse, those two axes, the major and the minor, are different from each other. So let's just go over some terms that may or may not be familiar to you. In a circle, of course, I've already spoken about the radius, and it's something that I would have expected you to already know about. And in this circle, we have the diameter, which is equal to twice the radius. So this is the radius, and this is the radius. And the circumference is the distance around the outside of the circle. So those are three common terms that you probably already knew. Now, there are some advanced terminology of geometry of circles that I just can't resist showing you, explaining to you. So, of course, we have the diameter, which we already saw, and the radius. Both of these are line segments. A line, when it has arrows on both ends, they go on forever. So when we don't have that line, we call them a line segment. So what we then see in this picture is that a radius is a line segment. It doesn't continue in both directions. And the diameter is a line segment. It does not go beyond the edge of the circle. A chord then is a line that touches two edges of the circle but does not extend beyond. A chord. A secant is a line that touches the circle in 2 points and continues on outside the circle. And a tangent is a line that touches at exactly 1 point. Exactly 1 point. So if we were to make comparisons, we might compare chords. A diameter is actually a chord. The diameter is actually a chord that passes through the center. And a secant would be compared to a chord, in that the secant is the line version, and the chord is the segment version. And the tangent is unique in that it has only 1 point. The other type of measure we have is an arc. An arc is a segment, because it has a fixed length, that's on the circumference of the circle. And lastly, when it comes to the areas inside circle, we have a segment which is bounded by a chord, and it is that area included inside that chord. A sector is an area swept out by an angle. So if we have an angle that we started drawing here and swept this out, then this area would represent a segment, a sector. So that is the difference between a segment and a sector. Now, of course, these two might become a little difficult to understand if it passes through the center. Then we might say that the area, that this is both a sector and a segment. So when a segment goes through the circle, it is a sector. And so we're just using the words segment and sector to define how areas are delineated. In our next installment, we are going to look more specifically at the geometry of an ellipse.